Hey, hi guys. I think we are live. Hi, good evening all. My name is Girish, and today we'll be doing a session on permutations and combination and probability. Let me know if you guys are able to hear me properly. You can just say if it is audible. We'll start now. Uh, okay. All right, cool. Okay, thanks. So yeah, hi, good evening all. Welcome to Cracku. Today we'll be doing a session on permutations and combinations and probability. We have already covered these two sessions. There are two sessions for PNC first and then probability. I remember that I took the session on probability, and in that we covered all the things very well. We also did some questions. Today we will be doing a quick revision because it seems it is a very important topic. It is also covered in your 11th and 12th. Today we will be doing it from the perspective of what kind of questions can be asked, and we will do a quick revision of all the things. I hope that you guys are preparing well for the exam. The exam is very soon. If you guys need any help, or if you guys are facing any issue, we have a WhatsApp group. You can find the link for that in our description. You can join that and you can ask all your doubts there. Further, we have also 5 free mocks for IIM Bangalore UG test. We understand that this is the first batch, and there's nothing which you can rely on, or you can resemble, or you can actually think that okay, what kind of questions can be asked. So we go through a lot of questions, and we saw what, and we decide, and we thought what could be asked, and then we prepared these 5 mocks. I'm sure that these 5 mocks would very well resemble the actual IIM Bangalore UG program. I would suggest you guys to appear for these mock tests. These mock tests are absolutely free. You can appear them at any time. Just go to Cracku IIM Bangalore UG free mock test, and then the first link obviously would be of Cracku. You can go to the mocks and appear. And one thing further, that mocks are very important because in your schooling and all, you might not have been into the process of uh, sitting for any competitive. So this is going to be mostly first of your competitive exam, and in that for 2 hours you have to sit and be very focused, appear for a lot of questions. So getting into that zone and be ready to face such a competitive exam, it is very important to practice for that. And for practicing, we have the mock test. Mock tests are very good tool to practice for sitting for 2 hours and focusing on the exam. So I would suggest you guys to voice is low. Okay, I'll tell the team. So it is very important for you to appear for mocks. You still have some time. I would suggest you guys to go through the mocks, appear for them, and practice through that. Next, we have WhatsApp group, as we just discussed. You face any issue, you can ask us in the WhatsApp group. We have the admins there, they will help you out. Also, if you want any further help, you can contact us on our helpline number. We also have complete course playlist that is free of cost. You can go to Cracku, you can just search for Cracku IIM Bangalore playlist, and you will get all the videos which is covering all the basic topics. So now we'll start. We have the topic as permutations, combinations, and probability. First thing, we will cover permutations. Now, I hope that you guys have covered this in your 11th and 12th, I guess. We'll start with the basic. Permutation is nothing but if there is a pool of things, you want to select some things and you want to arrange them. There are two processes. First is your selection. First is your selection, and then you want to arrange them. The sum of both this process becomes permutation. For example, there are 4 people, A, B, C, and D. You want to select 2 people for 2 seats. Let's say the seats are these: seat number 1, seat number 2. In how many ways you can arrange them as well as select them. So you can select two people as AB, AC, AD, BC, BD and CD. Now you have selected them. This is the first process. Second process is you want to arrange them. For every process there are two arrangements. This can be AB or BA as 1 and 2 and 1 and 2. Similarly, there are two arrangements for all these selections. So if you notice that this is a very small example, that there are 4 people, you want to arrange them for 2 seats. There can be very big numbers. For example, there are 100 students and you want to select any 2 and you want to arrange them. Now this becomes a very large process. You can't do that manually. For that we have this formula called NPR. N is the total number of things and R is your requirement, or the number of things you want to select and then arrange. And we have n factorial divided by n minus r factorial. I hope that you guys are aware of factorial. If you don't, let me just tell. If I say n factorial, this is nothing but 1 into 2 into 3 into 4 till n number. Or for example, if I say 5 factorial, this is nothing but 1 into 2 into 3 into 4 into 5. That's it. N factorial is nothing but multiply from 1 to all the numbers up till that particular number for which you are finding the factorial. Now, so this is a simple formula. I hope you guys are aware of it. For example, let's do this calculation using this. So we notice that for each there are 2 arrangements. So there are 2 for this, 2 for this. So in total we have 6 into 2, 12 arrangements. Let's try to do this here. We have n is equal to 4 because we have 4 people, 1 A, B, C, D, and R is equal to 2. We want to arrange them in 2 ways. If you put that into the formula, we have 4 factorial divided by n minus r factorial, that is 4 minus 2 factorial. 4 factorial is nothing but 1 into 2 into 3 into 4 divided by n minus 2 factorial. 4 minus 2 is 2 only. So 2 factorial is 1 into 2. If you cancel, we have 3 into 4, that is equal to 12, which is the same. This is how we do the permutations. We select something and we arrange them. Now, this is the first thing. Second thing, if you want to arrange all the things, for example, if you have 10 students in a class and there are 10 seats, you want to arrange all the 10 students. Now, this can be simply done in 10 factorial ways. So if you have n thing and you want to arrange all of them, that can be done in n factorial ways. Let's see how. Let's take the same example that there are 10 students and you want to arrange all of them into a sequence. So 10 seats are 1, 2, 3, 4 up till, let's say, 10th seat. Now for the first seat, how many options do you have? You have 10 students, anyone can sit on the first seat, so there are 10 options. Into, now for the second seat, how many options do you have? One of the students has already sat on the first seat, so you have 9 options now. Similarly, for the third seat, 2 students have already sat down, so there are 8 options. Similarly, there will be last seat and there will be 1 option only. 1 student left only, so only he can sit. So in this way, if you notice, this is nothing but 10 into 9 into 8 into 7 till 1. And this is nothing but 10 factorial. Multiply from 1 till that particular number is equal to that particular number factorial. So this is how, if you have n things and you want to arrange all of them, you can do that in n factorial ways. So this is permutations. We have this example. You can do this on your own. Let me know if you have any doubt. Okay, now we have permutations with repetition. For example, if there are 5 balls and there are 6 boxes. There are 5 balls and there are 6 boxes. and I want to put all the 5 balls. These balls are different and boxes are also different. If I want to put all the 5 balls into 6 boxes, now if you notice that, and for the first ball, how many options can be there? First ball can go into any of the 6 boxes. Now in the previous case, we were doing that for the first seat, there can be only one student. But in this case, for the first seat, there can be any number of students. Repetition is allowed. In the previous one, that we were doing arrangement of all the n things into n factorial ways, in that case, repetition was not allowed, because for one of the seats, there can be only one student. But here, we are saying that repetition is allowed. For example, if one person has sat on the first seat, more students can sit on the same seat. So here, for the first ball, there are 6 options. For the second ball, in how many different boxes can the second ball go? Again, there are 6 options, because repetition is allowed. Similarly, for the third ball, how many boxes are there? Again, there are 6 boxes. Similarly, for the fourth ball also there are 6 options. Fifth ball also 6, and sixth ball also. So if you notice, this is nothing but 6 raised to, sorry, there are 5 balls only. Fourth ball and fifth ball. So if you notice, when you have repetition, then you can write this in this form, that is, if there are n things and there are options, you can arrange them in n raised to r factorial ways. For example, here we have how many 4-letter strings can strings from A, B and C if repetition is allowed. 4 letters. So first letter, second letter, third letter and fourth letter. Repetition is allowed. It means for the first one, if I have selected A, for the second one also I can select A. Repetition is allowed. So for the first letter, how many options are there? We have A, B and C. So there are 3 options. Similarly, for the second one also I have 3 options. Similarly, for the third also 3 options, and for the fourth also 3 options. So if you notice, this is nothing but 3 raised to 4. Remember that what is n raised to be r, or you can understand it this way: in how many ways the thing that you are distributing or for selecting. I am selecting letters and I have these options. So first one can be in 3 options, second one also 3. This way, if you multiply, that will be easy. If you think that it should be 4 raised to 3 or 3 raised to 4, that might confuse you. So it is better that you first write down it in this form, and then you think, okay, I am distributing what thing? Basically I am selecting what thing? I am selecting the letters, that is A or B or C. So that has to be multiplied. The number of options has to be multiplied. That would be easy for you. Yeah, hi. Yeah, recordings for all the live sessions that we have done so far. We are taking the session every day from 8 to 9:30, and the recordings of all the sessions are available on our YouTube. So I would highly suggest you guys, if you want to revise any of the topics, although we are doing a revision series, but if you want to revise a particular topic in depth, you can go to that particular sessions recording and watch that. Also, if you like the sessions, I would suggest you guys to please like the session and comment on that, and you can also share it among your friends who are also preparing for this exam. So this was the one of the case where repetition is allowed. Next, we have permutations of identical items. For example, if I have 10 things, out of that 2 things are same and I want to now arrange them. Now in that case, I have got some of the things which are identical. Let's take a simple example. Let's take this example, that is, let me explain another short example. Let's say I have A, B and C. I have 3 options. I want to select 2 options. So how many permutations are available, or how many arrangements are available? I have AB, AC, BA, BC, CA and CB. Now in this case, the options were distinct. So I've got 6 cases. Now if I say I have these options A, B, I replace C with A. Now I have got identical items. If you notice the cases, permutations with identical items. Here we have identical items A and A. Now if you replace C with A in the arrangement, what we will be having? AB, A. C is replaced by A only, so A. Then BA, B and C. C is replaced by A only. Then we have CA, that is A, and then we have CB. C is nothing but A only. Now if you notice, when we use the identical items, the items are nothing but multiples or same cases. BA and BA, A and A, AB and AB. So whenever we have identical items, we can't simply do n factorial, because then we have multiple same cases. If you notice, AB and AB is same, A and AA is also same, BA and BA is also same. So whenever we have same or identical items, we subtract the cases or we remove the cases which are identical. How do we do that? Nothing but the number of items which are identical, we divide the n factorial with that particular number of factorial. For example, we have, let's do this one only. For example, I have this. In how many ways I can arrange this? I can arrange this in 3p 2 factorial ways. Again, I will do the same, but I know that I have A and A common. So I have 2 items common. Whenever the number of items which are common, you divide that with that number of times factorial. For example, another example here, we have level. If you notice, we have E 2 times. We have L, which is 2 times. So first thing that you do is n factorial. I have 5 items. I can arrange them, all of them, in 5 factorial ways. Now you divide. I know that E is 2 times and L is also 2 times. So I will divide this with 2 factorial into 2 factorial. 2 times because E is coming twice, L is also coming twice. For example, if L has come thrice and we have E1 and V1, then we would have run 5 factorial divided by 3 factorial. This is another case. So any number which is coming n number of times, you divide the whole factorial or whole n factorial divided by that particular number of times of factorial. P1 factorial is, if that number is coming 2 times, that will be 2 factorial. P2 can be, because there can be, in one arrangement there can be multiple identicals. Here we had E coming twice, L coming twice. Let's do a question and we'll see how many of you can do this. For example, I have apple. And A. Let's say this is the word. In how many ways can you arrange this? Let me see how many of you can get it correct. We'll wait for 1 minute. Come on, guys. Okay, so we have 1, 2, 3, 4, 5, 6, 7. We have 7 items. We can arrange 7 items in 7 factorial ways. Now we will divide. What we will divide? we divide A is coming twice. So A is coming 2 times. Then we have P coming twice. And then we have E is coming twice. So we'll divide this whole factorial with 2 factorial for A into 2 factorial for P into 2 factorial for E. If this had been 3, this will become 3. So this is how you do it when there are identical items. Let me know if you guys have any doubt here. We'll move on now. Now we have circular permutations. Basically, the items are there, but you want to arrange them in circular form. It can be circular table or circular any kind of table or seatings or any arrangement which is in circular form. For example, let's say there are 6 students. They have to be arranged in a circular dining table. Now, how do you do it circularly? The whole idea for circular table is, for example, I have this circle. These are the seats. Now, if first person sit, if he sits here, all the other seats are as it is will be in same format. If he sits at any of the seats, for example, let's say 1, 2, 3, 4, 5, and 6. Let's say the first person sits here. For him, there are 2 empty seats here, 1 empty seat on the opposite side also, and other seats are in 2 different directions. But if the same person sits here, again for the same person, the seats will look same. There are 2 empty seats on the other sides, 1 empty on the opposite, and same here. Similarly, if he sits here at the third position, there will be same arrangements. So basically, for the first person who sits, it will be same arrangement. But for the second person, the sitting arrangement for the second person will be decided where the first person is sitting. For example, first person sits here. For him, all the arrangements are as it is. But for the second person, if he sits here, it will be to the left of him. If he sits here, it will be second to the left. Here, it will be third to the left. Here, four to the left or second to the right. And here, immediately right. So for the second person, the arrangement was decided based on the first person. Similarly, for the third person, arrangement will be decided based on first and second person. Only for the first person, all the arrangements are same. But for every next person, the arrangement will be different on different seats. So here, what we do is whenever we have n items need to be arranged, we minus it by 1 because for first person, all the arrangements are same. So we don't calculate the arrangement for that person. You can remember it by this logic. So if I have 6 students, I can arrange them in 6 minus 1 factorial ways, which is nothing but 5 factorial ways. Whenever you have n number of items need to be arranged in a circular setting, just subtract 1 from it and find the factorial of that. 5 factorial is nothing but 1 into 2 into 3 into 4 into 5, which is nothing but 120. So there can be 120 arrangements. Let me know if you guys are clear about this. So whenever you have n things to be arranged in circular setting, just subtract 1 and find that factorial. Now if you have anything which is in anti-clockwise and clockwise same, for example a necklace, let's understand that. If you have necklace, let's say it is blue here, let's say there are beads, there are 4 beads, let's say blue, yellow, green and red. Now necklace is a circular arrangement, but it is something which can be flipped. For example, if it is this face, if you flip it, then it will be red, yellow, green, and here it will be red, blue and green. Now if you notice that this is one of the arrangement which is necklace, first arrangement. If you flip it, these two items will be reversed, green and red. So whenever we have such cases where either clockwise or anti-clockwise is same, or we have a necklace where flip can be done. So for each item, for each thing, each arrangement, there can be a duplicate arrangement itself. So we have to divide it with 2 to avoid that duplication. So whenever you have a case of necklace within the circular arrangement, or clockwise or anti-clockwise is same, you divide that with 2. So here, for example, again, if I have 6 beads to be arranged in necklace, so how many ways are there? So first, because this is a circular arrangement, this can be done in 6 minus 1 factorial ways, that is equal to 5 factorial ways. Second, because it can be flipped, so every case already has its duplicate case, which is opposite case. So we have to remove that duplication, so we have to divide it with 2. So this should be the arrangement for 6 beads. I hope this is clear. So far we have done permutations. This is one of the practice questions. I would suggest you guys to do it on your own. We have more questions lined up in a timed manner after some slides. Now we have combinations. So if you notice, in the permutations we were selecting as well as we are arranging. Now in combinations we are just selecting. We don't care about order, or we don't care about the arrangement. So combination is nothing but selection where order does not matter. We don't care. For example, if I have 6 students and I want to select 4. So I don't care where they sit. So I want to just select them. This can, for example, let's take another small example. 3 students. Let's say the students are A, B, and C, and I want to select 2 students. This can be done AB, AC, and AB, AC, and BC. This can be done in 3 ways. I don't want to select. I don't want to arrange. If I want to arrange, then for this case another arrangement will be BA, which is opposite arrangement. But I don't want that. I want to just select the students. I want just the selection and not the arrangement. In those cases we do the combinations. The formula for combination is same as formula for permutations. It's just we divide with r factorial. Why do we divide? Because in permutations we are arranging. To remove the arrangement we divide with the r factorial ways. Let's do next. In next slide we have covered the relation between permutations and combinations. So here if you notice, NPR is nothing but n factorial divided by n minus r factorial. That is equal to NCR is nothing but n factorial divided by r factorial and n minus r factorial. If you notice, all the things are same. It's just this r factorial is additional, and this r factorial is for what? This is for arrangement, because permutation requires arrangement but combination does not, so we divide with r factorial. To equate that to permutation we have to remove that r factorial. For that we multiply with r factorial. R factorial will cancel this out and permutations and combinations will be equal or equate. This equation shows the relation between them. Okay. Now this is one of the biggest thing that students worry about. So basically there are distributions, and how we deal with distributions. So we have 4 cases for distribution, and we will be covering all 4 here. Basically it's just the concept that you need to understand for each case. How do you handle or how do you solve that? So we'll do all the cases. The first case is distinct balls and distinct boxes. For example, I have distinct things and I want to distribute them among distinct boxes. For example, there are 3 balls, 3 different balls. And there are 2 boxes. we are covering distinct balls and distinct boxes. So first case, 3 different balls and 2 different boxes. Now let's say the balls are red, blue and green. The boxes are X and Y. Okay. Now, so if you notice, we have 3 balls. For the first ball, how many different cases are there? I can have 2 boxes and 2 different boxes. It can be either X or Y. So there are 2 cases. For the second ball, how many boxes are there? Again, we have 2 boxes and 2 different boxes. So we have 2 cases. And for the third ball also, in how many ways I can put the third ball? Again, I can put the third ball in 2 cases or 2 boxes, that is 2. So it is nothing but 2 raised to 3. So whenever you have different balls, different things need to be distributed among different things, you simply do an r raised to n. N is the number of things, r is the number of options do you have. So each ball has r choices. So how many times r will come? The number of times the balls are there. So this is a simple case for distinct to distinct things. Whenever there are n number of distinct things need to be arranged in n number of different boxes, then you simply do r raised to n. Let's do the second case. Now in second case, balls just become identical. Now there are no distinct different balls. All the balls are identical. So what can we say? Let's say all the balls are red balls, but the boxes are different. We have 2 boxes. So we can say that x plus y has to be equal to 3. Or basically in x box and in y box, in total these 2 boxes should contain 3 balls. All the balls are same, so we don't need to worry about different distinct balls. In how many ways we can make it? Now it can be like this box has 0 balls, this has all the 3 balls. This has 1 ball, so second box will have 2 balls. The first box will have 2 balls and second box will have 1 ball. And the first box will have 3 boxes and second one will have 0 balls. So either you can make the case, or if the equation is lengthy, what you can do is you can remember this formula, that is n plus r minus 1 c r minus 1, n plus r minus 1 c r minus 1. Basically this is a formula for combinations. How many different combinations can you make? For example, there are n balls, n we know is 3 and there are 2 boxes, so r is equal to 2. Now if you put that here, so we have 3 plus 2 minus 1 c, r minus 1 is 2 minus 1, 3 plus 2 minus 1 is 5 minus 1 4, c 2 minus 1 is 1, 4c1 is nothing but 4 only, which is what we have done. First case, second case, third case and fourth case. So whenever you have such cases, you make it a linear equation. The number of balls, the number of things you want to arrange or you want to distribute is identical, and the boxes or different things you want to distribute amongst, those are distinct. So those distinct things are different variables, and the sum should be equal to the total number of things you want to distribute. I want to distribute 3 identical balls, so x plus y is equal to 3. Then either you make the case or you use this formula. The formula is simple, n plus r minus 1 c r minus 1, and c refers to combination, and for the formula for combination you have just covered. This is the second case. Now for the third and fourth case, it's all about cases. But before doing the third one, I want to tell the fourth case, and I will tell the third case from that only. Let's do the fourth case first. Fourth case says that there are identical balls and identical boxes. For example, 3 red balls and there are 2 same boxes. So we have 2 boxes here. Let's say this is one box, this is another box. The boxes are same, so we don't need to arrange them. Earlier the boxes were different, so we considered them as 2 different boxes as x and y. Now here we have 2 same boxes, and the balls are also same. Just make the cases. So first box can have 0 balls, second box can have 3 balls. First ball can have 1 ball, 0 3, 1 2, just that. You don't want to make 2 1 and 3 0. These are 2 cases will not be considered. Why? Because 2 1 is what? This has 2 and this has 1, and you have already considered this box has 1, this box has 2, but they are not different because the boxes are same. If boxes are same, you can interchange them. So these 2 cases will not come. So either it can be 0 3 or it can be 1 2. There cannot be further cases that we did in the previous case. In this case, we all need to worry about distribution, and we don't need to worry about if the same case repeats or not, because the boxes are identical. So whenever you have boxes are identical, just make the cases what can be the options. For example, let's say we have one case. I need to arrange 5 same, let's take a big number, 6 same pens in 3 different boxes. Now in how many ways I can arrange 6? Because boxes are same, I can do 0 0 6, I can do 0 1 5, I can do 0 1 0 2 4, I can do 1 1 4, I can do 0 0 3 3, I can do 0 1 2 3, I can do 2 2 2. All these cases are possible. I don't need to arrange like 0 0 6 and then 0 6 0 and 6 0 0, because the boxes are same. Now if we talk about the third case, it is same about the balls are different. So this was the fourth case. Now let's do about the third case. This was the fourth case. In third case, it is the same. I have 3 balls, but now the balls are distinct. So let's say there are 3 balls, red, green and yellow, and I have same boxes. Let's say I have 2 boxes. Now for 2 boxes, how many different arrangements are there? So we have, it can be in these 2 boxes, it can be either 0 3 or 1 2. Now for each case, make sub cases. For the first one, all the 3 balls are in this box only, and all the 3 balls are different, so there can be only one case. But for this second case, which is 1 and 2, first box has 1 ball, second ball has 2 balls. For this, you have to think about which is that 1 ball, because the balls are different. So this ball can be red, so this has 2 other balls. This can be yellow, so this is another balls. And then we have green. This can be green, there are 2 other balls. So there are these 3 cases. So we have in total 4 cases if we want distinct balls to be in identical box. If this would have been identical to identical boxes, we would have only 2 cases, 0 3 and 1 2. We would not be required to do this, because in the fourth case the balls are also identical. So there can be 0 3 and 1 2 only for the fourth case. But in third case, the balls are different. When the balls are different, you have to think about which is that 1 ball. That ball can be either red, that one ball can be either green, or that ball can be either yellow. So in all, third and fourth case requires you to make cases, and that is what you need to understand, that you should not be missing out on any of the important case. If you miss out on any case, then it will be a big issue, because if you miss out on one case, then the answer will be incorrect, obviously. So for third and fourth, just make the cases, and for the first and second, you can use this direct formulas. I hope this would be clear. Just let me know if you have any doubt. I'll be happy to clear your doubts. Next we have is probability. Now I hope that you guys are doing probability from your 10th and 11th and 12th. It is nothing but you find out the chances of happening any event. For example, what are the chances of for example, what are the chances of it rains today? There can be any number of chances. If it rained yesterday, there can be 10%, 20%, 30% chances. So it's all, probability is all about finding out the chances. And how do you find out? What is the total number of outcomes are there, and what are your favorable outcomes, or what is the number of favorable outcomes refers to what do you want, or what are the chances of occurring your event. Now obviously you know that probability is between 0 and 1. That is, it can be 0 also. For example, any event which cannot happen. For example, what are the chances of selecting a leap year out of 2021, 2022 and 2023? Now in all these 3 years there is no leap year, so there are 0 chances. And similarly, if I say what are the chances of selecting a leap year out of 2024 and 2028, now both these years are leap years, so the chances will be 100%, which is equal to 1. So you get that anything that cannot happen, so the chances will be 0% or probability will be 0. And for something which will definitely happen, the probability or the chances will be 100%, that is equal to 1. Now one more thing is there, that probability of happening something and probability of not happening something, that should be equal to 0. That should be equal to 1, my bad, sorry. So for example, let's say if it rains today or if it does not rain today, the probability of both the things has to be equal to 1. That is here, if you want to find out the probability of not happening something, just subtract the probability of happening something from 1, because probability of happening something plus probability of not happening something, that is equal to 1. If you want to find out this, take this to the other side in subtract. This is very basic probability. I hope that you are aware of this. We have conditional probability. After that we will do some questions. Now conditional probability is nothing but you find out the probability of happening something considering something already has happened, or based on something has already happened. Now what is the probability? All you need to do in this case is you find out the next probability. You find out the probability of that has already happened. From that, find out the probability of the event that you want to find. For example, let's say a bag has 4 red, 5 blue and 1 green ball. A ball is drawn, not replaced, okay, and another ball is drawn. Find out the probability that the second ball is blue given that the first ball is red. Now you are given that one event has already occurred, that first ball has to be equal to red. Now find out the probability that the second ball is blue. What do? In that case, first in denominator you find out the probability of happening the second event. Probability of A is to B refers to probability of happening A considering B has already happened. So B is the second event, but it has already has happened. So probability of finding B, that what is the chances of happening the event that has already happened, and in numerator you put what are the chances of happening both the things together, that the first event also occurs and second event also occurs. For example, here what is the finding of what is the probability that B event has already occurred. B is the event that has already occurred, and we are told that the event is the first ball has to be equal to red. The first ball has to be equal to red. It means here we have 10 balls. Out of 10 balls, what are the chances I get a red ball? There are 4 red balls. So here we have 4 raised to 10. Probability of getting the event which has already occurred. In the first case, we have probability when A has also occurred and B has also occurred. So first ball has to be equal to red. The chances are 4 raised to 10. Into second case, second ball has to be equal to blue. How many blue balls are there? There are 5 blue balls. Divide by 9, because one ball has already taken out and it is not replaced. So now I have 9 balls left. So for second balls there are 9 options. If you subtract, this will be equal to 2 and this will be 2. So this will be equal to 2 by 9. If you solve this, this is nothing but 2 by 9 into 10 by 4. This is 2 and this is 5. So this will be 5 by 9. So this is how you solve. You have the direct formula, that is probability of happening the event which has already occurred. That should be in the denominator, and in numerator it has to be probability of happening both the events. That is the event that has already occurred and the second event for which you are finding out the probability. This is how you find out the probability of happening event A considering event B has already occurred. That is called conditional probability. Next we directly have the questions. So we'll be doing combined questions from PNC and probability, and all the questions are something which can be asked in the exam. So I hope you would be clear about this. If you have any doubt, you can ask, and we'll see how many of you are able to solve the questions. Your time starts now for this question. You have 2 minutes. This is a pretty easy question. I hope that you guys are able to solve this. Let's see how many of you are able to solve this. You can write your answer in the chat box. All right. So we have a bag contains 5 apples, 7 oranges and 8 mangoes. Okay. So in total we have 5 plus 7 plus 8. So in total we have 20 fruits. Now 3 fruits are drawn from 8 without replacement. Now remember that this word is very important. Without replacement. It means after every after every fruit you take out, the left fruits will be 1 less. So for taking out the second fruit, you have to be you have to consider that if it is without replacement or with replacement. For example, let's say there are 10 balls. I take out 2 balls with replacement. Or second case, I take out 2 balls without replacement. Now for the first one, you find out the probability out of 10, and for the second ball also you are finding out the probability. With 9, because it is with replacement. So here what you are doing is with replacement. It means you are taking out 1 ball, you are putting it back, and then you are again taking out. So in the first case, when you take out, there were 10 balls. Now you had with replacement. It means after taking out, you had already put that. You have already put this that ball that you took out in the bag. So for the second ball also, the number of when you were taking out the second balls, there were 10 balls only in the box. But if you do it without replacement, it means you are taking out the first ball, but you are not putting it back. You are taking out the second balls amongst the left balls. So here the probability for the first ball will be numerator, you can find out of 10 balls, and for the second one you are find out the probability with 9 balls, because now for the second ball, because you didn't put it back, it is without replacement, you didn't put it back, so there were 9 balls left. So this is how you have to use this with replacement and without replacement. In the question we are given that the replacement is done without replacement. So it took out 3 balls consecutively and he didn't put it back. What is the probability that none of them is a mango? Mango should not be there. It can be either of other 2 options, but there should not be mango. So I don't want mango. It can be 5 apples or it can be 7 oranges. Now you don't need to consider for them separately. Consider as one, because it can be either one of the option. So I want either this or this, that is 12. So what is the probability of getting one of these 12 out of 20 balls? This is the first ball. Sorry, first fruit. So for the first fruit, out of 20 fruits, there has to be 12 fruits if you don't want a mango. Now if you have taken out one from here and one fruit here, for the second fruit there are 19 options, and from 19 you want 11 because you have already taken out one of them. Similarly for the third fruit, you have already taken out one more here. Now you have 18 fruits left, and from 18 you want 10 because you don't want mango. So in each case, if you notice, the gap is of 8 and the 8 is the ones mangoes you don't want. So the probability will be nothing but the multiplication of all these 3 probabilities. If you solve this, this will be 2, this will be 6, and this will be 3. So this is 11. 19 into 3 will be 57. 11 divided by 57, which is option B. Hi, yes guys, the free mock test, that is the sample paper, is already out. You can go to their website and access that there. We'll be also putting that into our groups, so you can also check out there. So yeah, this was the first question. It was simple. All you needed to understand was the without replacement part, and how do you do if you don't want, if there is something like, if none of them should be particular of the thing or particular item, then you consider the remaining items only. Let's solve this. This is a slightly logical question. All you need to do is just remember, just try to understand the logic, what is asked. Now, it says that in how many ways can A, B, C, D, E and F be arranged such that A always comes after F? It means F should be left of A. Now, let's say we make A, B and C. We arrange A, B, C. In how many ways we can arrange them? We can arrange them as A, B, C, A, C, B. Then we make B, C, A, B, A, C. Then we have C, A, B and C, B, A. Now let's find out the cases where A is to the left of B. It is here, it is here, it is here. So there are three cases. Now let's find out B is to the left of A. Now there are three cases where A is to the left of A. Then there will be three cases where B will be to the left of A. It means there are equal cases. Let's do the same for any other options. Let's do this for C is to the left of B. C is to the left of B is here, it is here and here. So there are three cases. It means in another three cases B will be to the left of C. Similarly, we can do for A and C also. So what you understood this, whenever you find out the total number of cases, in half of the cases one of the number will be ahead of the other one and in remaining one it will be behind. So here we have A, B, C, D, E and F. So there are 6 items. 6 items can be arranged in 6 factorial ways. That is nothing but 720. Out of this, all the 720 options or 720 arrangements, half of the times A will be ahead of F and in remaining half F will be ahead of A and they will be equal. So in 360 arrangements A will be to the left of A and in 300 and remaining 360 arrangements F will be to the ahead of A. So I want this option. This is possible in 360 ways, which is option A. Whenever you are asked something like A is to the left of A or A is to the right of A, you just find out the total arrangements and divide it with 2 because either it has to be left or it has to be right of particular something, and the both the cases has to be equal. There has to be equal number of cases for both. So if there are 720 arrangements, half of them will be this and half of them will be this. This was one of the logical question I would say, but I would suggest you guys to remember this concept. It is going to be heavily applied or it can be asked. This is the third question, again logical question and also an easy question. Let's see if you are able to do this. For the guys who are asking for the sample paper, I would suggest you guys, what you can do is in the description of this YouTube live, we have the link for WhatsApp group. I would suggest you guys to join that WhatsApp group, and within that WhatsApp group, we have shared the link for the sample paper. You can access that. Okay. Now it says that a Arjun, Bala, Kathy, Dinesh and Isha sit in a horizontal line. What is the probability that Dinesh and Isha are sitting together? Okay, this is this is a logical question, and there is a particular pattern to solve such kind of question. Now let's say we have A, B, C, D and E. So we have 5 items here. I want Dinesh and Isha to be always together. Let's say we have A, B, C and D and E are always together. Let's say they are one club only. So now we have A, B, C, D. We have 4 things. I can arrange 4 things in 4 factorial ways. But remember that D and E can also be arranged in 2 ways. It can be DE or ED. So for each case there will be 2 further cases. So I will further multiply it with 2. So these are total number of cases I can make. This was slightly easy question but logical question, and this is a fixed pattern. Whatever things you want to be together, just consider that as one block, not as 2 separate blocks. If you consider that as one block, then the remaining pairs, arrange them. That can be done in 4 factorial ways, and further for each block interarrangement is also possible. So multiply with the number of cases for each interarrangement. 4 factorial is nothing but 4 into 3 into 2 into 1 and into 2. This is nothing but 12 into 48. So there are 48 cases. Now we need to find the probability. This is the favorable cases. What are the total number of cases? The total number of cases is in how many ways I can arrange all the 5 things. I can arrange them in 5 factorial ways, and 5 factorial is nothing but 120. So out of 120, 48 cases will be there when D and E are together. This is 48 by 20 is nothing but 2 by 5, and this is equal to 0.4. So the answer has to be option D. I hope this was this is clear. Let me know if you have any doubt. We'll move on to the next question further. Okay. This is again an easy question. Just make the cases. Okay. So it says that a coin is tossed 4 times. What is the probability that at most one head turns up? Okay. Now, if a coin is tossed 4 times, for the first one, there are 2 cases. It can be either head or tail. Similarly, for the second one also there can be head or tail. Similarly, for the third one also there can be head or tail. Similarly, fourth one. So there are in total 2 and 2 and 2 and 2. There are 16 cases. Okay. So now there are 16 cases in total. Out of that, I want the cases where there has to be at most one head turns up. Now, okay. Let's make the cases. I want at most one head. First case, there is no head at all. And second case, when there is one head. These are the only two cases possible. So when there is no head, it means all the items are tails. This is possible only in one way. And for the second one, there is one head. Now one head can be occurred at any of the place. So this can be like heads, tails, 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 or tails, heads, tail and tail, or tail, tail, head and tail, or tails, tails, tails and heads. So there can be 4 positions of heads if there is only one head. This can be possible in 5 ways. So in total, if I want at most one head, there can be 1 plus 4, 5 favorable cases. So the favorable cases are 5 out of total 16 cases. This is the correct answer, which is option A. Yeah, this is an interesting question. I hope that you guys really like this question. It applies just the logical understanding of the question, and you can figure this out. You have 2 minutes for this. All right. Okay, it says that a point is chosen at random inside a square with an area of 100 centimeters square. Now, if you notice that it is a square, okay, and we are given that the area of this square is 100 centimeters square. To find out the area of a square, it is nothing but side into side, or we can say side square. So the area has to be equal to side square, or 100 is equal to side square, or this is nothing but 10, 100 is nothing but 10 square. So side is equal to 10. So we can say that this side and this side is equal to 10. Okay, from the area we have find out the sides. Okay, now it says that inside this square there is a circle inscribed that touches all the four sides. Okay, so there is a circle like this. Whenever you have a circle inside a square touches all the all the side, it means the diameter of that circle is equal to length of the side. Because let's say from this point, if I drop a perpendicular, this will be nothing but the diameter, and we know this is nothing but the length. So this whole is 10. It means this is 5 or this is 5, or basically the radius of the circle is equal to 5. Okay. Now I want the probability of that chosen point. The point is chosen to be outside this circle. So the point should not be inside the circle, it should be outside the circle. What is the total area within the square which is outside that circle? So area of the square we know. We need to find the area of this circle, and I don't want the point to be within that area. So area of this circle is nothing but, we know that area of a circle is pi r square, that is equal to pi into r. R is 5, 5 raised to 2, 25. So area of the circle is 25 and the area of whole square is 100. I want the area of the outside part, these parts, not the circle one. So I can subtract that. So area outside circle is equal to, from the area of the square which is 100, I will subtract the area of the circle which is 2 pi, 25 pi, and this is something we want, and we want the probability. Probability is, what is the total probability of choosing a point, what is the total area possible. It can be anywhere inside the square, which is equal to 100, that is the area of the square. Now if I want, my favorable outcome is, I want it to be outside that square, which is this area, that is 100 minus 25 pi. If I solve this, or if I take out 25 common, I will have 4 minus pi divided by 100, or I can cancel this out. So I will have 4 minus pi divided by 4. This should be the probability, which is option B. Let me know if you guys have any doubt. This was slightly logical question. Okay, let's solve this another question. Yeah, so guys, for those who are looking for the analysis, so general idea so far, the analysis done by our team is that the questions that are there in the sample paper are slightly easier, on the easier side. It might not be the actual difficulty level, but let's see, we don't know. The questions in the sample paper seems to be slightly on the easier side in English and logical reasoning section. Let's see how it goes. We'll be further posting the complete analysis in the WhatsApp group, and we'll be also looking for creating a video if it requires. Alright, it says that two standard six-sided die are rolled simultaneously. What is the probability? The sum of the numbers is either 7 or 11. So sum is either 7 or 11. So what are the cases in which we can make to get the sum as 7 if we roll two die? So it can be the first one has 6, second one has 1, or another one will be 1 and 6, and the second one will be 5 and 2, or 2 and 5, and it will be 3 and 4, sorry, 4 and 3, and 3 and 4. So we have got 6 cases for 7. Okay, now we have 11. So 11 is only possible in 6 and 5 and 5 and 6. So there are only 2 cases for 11. What are the total number of cases? On the first die, there can be 6 options. In the second die, there can be 6 options from 1 to 6. So in total, there can be 36 cases. Out of those 36 cases, our favorable cases are these 6 and these 2, which is 6 plus 2, 8 cases. If we divide with 4 to the numerator and denominator, this will be 2 and this will be 9. So the probability has to be equal to 2 by 9, which is option A. Slightly on the easier side. Okay, this is an interesting question. We have done this. In one of the slides we covered this concept. Just try to remember that concept. Alright. So the question says that in how many ways can 4 men and 4 women be seated in a circular table? Remember, circular table, such that no 2 men sit next to each other. Okay, so this is only possible when we have, let's say, these. There has to be man, man, man and man. In this way, no man is together and there is one woman in between them. So we have to make 4 men on each after a gap of 1 chair, and then we have to make the remaining 4 women. So we can do it either way. Either we make the women first and then remaining man, or we make the 4 men first and then remaining women, or vice versa case. So let's say we first ask all men to sit. all 4 men at 4 different chairs. Now, whenever there is circular table, remember that the first arrangement is always n minus 1 factorial ways. I want 4 men to sit. That can be possible in 4 minus 1 factorial ways. Now, I want all the women to sit. Now, for all women, this is possible in 4 factorial ways. Now, you will say that why not 4 minus 1 for this also? Because the n minus 1 is always done for the first person to sit, and not because after 4 minus 1 the man has already sat. So when people have already sat on the circular table, the next one we don't do this. We do this only for the first seat. So when all men have sat, the remaining women, that these 4 chairs, they can be arranged in any of the 4 factorial ways. So for the first 4 men, this is possible in 4 minus 1 factorial ways, which is 3 factorial. And then remaining 4 women can sit in 4 factorial ways. You can do it opposite way also, the answer will remain the same. 3 factorial is nothing but 3 into 6, 4 factorial is 24. If you multiply, this is equal to 144. So the answer has to be option C, 144. I hope this is I hope that you understood this. It was nothing it was slightly logical. Only you need to remember that n minus 1 is not done for every set of people who sit on the table, circular table. It is done only for the first set of persons who are sitting. That's why for the first set we have done 4 minus 1 factorial, and for the second set of women sitting we didn't do the same. Next we have, this is the last question of the day. Let's see how many of you are able to do this. All right. So it says that how many different ways can the letters of the word this foundation be arranged such that the consonants have to come together? Now we did a similar question like this, but here if you notice we have identical items. We have O twice, N twice. Let's see how do we do this. First let's separate the consonant and vowels. So we have F, O, U, N, D, A, T, I, O and N. So these are the consonants and these are the vowels. We want the consonants to be together. So let's just understand that. Let's just assume that the consonants, that is this, is nothing but one block. As we have O, U, A and I and O, that all the consonants are one block. So in total we have this one block plus these 5. So we have 6 items because I want the consonants to be together. So there are 6 items. They can be arranged in 6 factorial ways. But in these 6 items, this one and this, there are O coming twice. So whenever any number come n number of times, we divide that with n factorial. Because O is coming twice, we need to divide it with 2 factorial. Now this is the arrangement for items. Now within that block also, there are 5 items and they can also be arranged. So the 5 items can be arranged in 5 factorial ways. Now within that also n is coming twice. So again I have to divide with 2 factorial because n is coming 2 times. This will be the total number of arrangements. Let's solve. 6 factorial is nothing but 720. If you multiply 6 into 5 into 4 into 3 into 2, you'll get 720. Divided with 2 factorial. 2 factorial is 2 only. Into 5 factorial. 5 factorial is nothing but 120. That is 5 into 4 into 3 into 2 into 1. It will be 120. Divided with 2 factorial again is it 2. If you cancel this out, this will be 360. Into, if you cancel this, this will be 60. So it will be 6 into 6, 36 and 6, 18, 21. So 21,600 is the total number of cases you can make if you want all the consonants to be together, which is option B. So this was the class, guys. We covered the important concepts of permutations, combinations and probability. Then we did questions based on that. Next we have we'll further suggest you guys to appear for the mocks if you have not appeared. The mocks are going to be very important, and the students who would have appeared for all the 5 mocks, I would say, then they will have an extra edge because they have the capacity to sit for 2 hours, concentrate, and also can see what are the different kind of questions can be made for on a competitive exam level for IIM Bangalore. So I would highly suggest you guys again to appear for these mocks. And also we have the WhatsApp group. I would suggest you guys to join the WhatsApp group if you have not. We'll be putting all the important updates there. The sample paper is released. We have already put that in the WhatsApp group. We'll be thinking of making a video if there is a need be. And if you guys have any doubt there, you can ask us in the WhatsApp group. Also, we have the complete course playlist for IIM Bangalore UG. Just go to Cracku and just go to Google and search Cracku IIM Bangalore UG playlist. You can find out the videos. If you have any further doubt, you can mail us. You can contact us on the helpline number. We'll be happy to help you out. With that, all the best. Good night.